Welcome to Study Loop.
In the given question, we are told that the population of a southern city follows the exponential law. Now we are asked if n is the population of the city, if n is the population of the city and t is the time in years, express n as a function of t. So what we can do over here is we are told that this is the first part of the question. We are simply told that the population of the city follows an exponential model. So we can model a general exponential equation which is of the form n of t is equal to n0 times e to the power of k times t. Over here what we can say is that n of t would give us the population of the city after t years. N0 would give us the initial population of the city from whichever year we are starting to measure, and k is a constant and t is the time in years. So we can call k the growth rate as well, since the population goes on increasing over here. And now what we are asked in the second part of this question is that we are told that the population, if the population doubled in size over 19 months and the current population is 30,000, what will be the population 3 years from now? So we are being told that to assume the initial population to be equal to 30,000, and we are told that this would double in 19 months, right? So 19 months means how much year can we take? So 19 months, right? So 12 months is an year, 12 months plus 7 more months, right? So what we can do over here is we can convert the number of months into years by simply dividing 19 by 12. So when we take 19 by 12, what we get is 1.5833 years, right? So this is going to be our t. We are told that in 19 months or 1.5833 years, the population would double, which means if we are going to take n of 1.5833, what we should get is the double of the initial population, which is 60,000, right? So this should be equal to, we can equate it with the formula that we have mentioned above, which is n0 times e to the power of k times t, and we can substitute for n0 as 30,000, and we can take the value of k we don't know yet, and t is what? T is 1.5833, and now 60,000 is what we would have on the left hand side. We can simplify this equation and write 60,000 divided by 30,000. 60,000 divided by 30,000 is equal to e to the power of 1.5833 times k. So 60,000 by 30,000 is equal to 2. Now what we are going to do is to take the natural logarithm on both sides of this equation, and we will have an expression of this form. The reason why we are taking logarithm on each side is to use a property of logarithm that says when we take the natural logarithm of e raised to some power, say a, the value of this expression would be equal to the power of e, which over here is a. So natural log of e to the power a is equal to a. So similarly, natural log of e to the power of 1.5833k would then be equal to 1.5833 times k. So k is then equal to 1.5833 divided by the, it would be the natural log of 2 divided by 1.5833, natural log of 2 divided by 1.5833. When we take the natural log of 2 and divide it with 1.5833, what we get as the value of k is 0.437778. So now what we can do is, we have found all the constants in our equation, in our exponential model, which is n of t is equal to n0, which is 30,000, times e to the power of 0.43778 times t. So now to find the population after 3 years, we could simply take t is equal to 3, that is n of 3 would be equal to 30,000 times e to the power of 0.43778 times 3. So when we take 0.43778 times 3 as the power of e, that is e is raised to this power, what we would get is a value which is 30,000 times 3.7184. So 30,000 times 3.7184 is equal to 111,552. So this would be the population of the city after 3 years. Population of city after 3 years. So this is how we solve the given question. In the second part, we can see that a few of the values were given to us. So we first found what was the value of k, and then after finding the value of k, we can just substitute the value of t in order to find the population of the city after 3 years, which is 111,552. So this, I hope you understood both the answers. Thank you.